So it's still example 23. I'm now going to go over the actual integration bit, which is pretty easy. Okay. Some of you might be wondering about the hat stand. If you check out some of the older James Bond films, when he goes into M's office, he used to actually take off his hat and just throw it onto the hat stand right in front of Miss Moneypenny. Okay, because James Bond used to wear a hat, you know. And so, yeah, I don't have any other James Bond props, okay? So, yeah, that's the best I could do. There's a hat stand somewhere in the office sometimes, okay? Right, the actual integration of this. So what you want to do is work out the area of that. See the shaded area? If you want to work out the area of that. If you remember, you need to work out the area of everything underneath the black curve and then subtract everything under the area of the blue curve. Because obviously, if you work out the area under the black curve and subtract the area under the blue curve, you get what's left. That's the shaded area. Okay. So what you want to do is you want to subtract the area under the black curve, so sine 2x, subtract the area under the blue curve, sine x cos squared x. And you can write it out just like that. And let's not forget to put the limits in. 0 pi over 2. Okay. You can write it as separate integrals if you want, no point. Okay, just if the limits are the same, 0 pi over 2, just write it as one single integral. There you go. And this is a simple integral, okay? It's an inspection integral. There's no need for any method like by part substitution or anything like that. So the first one, sine 2x, you should know how to do that, of course. So negative half cos 2x. Okay with that? Remember, I hope you're differentiating by checking as you go along, because it gives you good practice with differentiation. So differentiate that, 2 times negative half is negative 1, and then you've got the differential of cos x, which is negative sine, so that becomes positive sine 2x, so yeah, that. And then this one, yeah, also an inspection question. Pause the video maybe, if you don't see what it is, okay, but only leave it, 1 minute. Not got it yet? I'll give you a clue. So you've got a single trigonometric term of sine and a multiple power of cosine. That's your clue. If that wasn't helpful enough, then try this, cos cubed x. See what happens. Okay. Now when I say try that, what I mean is in your head or in a note maybe on the side, you try differentiating cos cubed x. See what happens. Okay. And of course you're going to get 3 cos squared x times by negative sine x. Isn't that 3 cos squared x times negative sine x, okay? Which is very nearly this, isn't it? What you want, of course, is that, the cos squared x sine x bit, and that's the cos squared x sine x, okay? So clearly then, if you divide that by negative 3, so it's negative a third, that becomes positive, cos squared x sine x, that's what you want, okay? So your answer here is going to be positive 1/3 cos cubed x, okay? And if you don't believe me, just differentiate that, okay? But here it is, here's the working for it. There, and you get your answer, okay? Yeah. Let's just put the limits in, shall we? Let's just check, see if the text did any more working. No, they didn't. So they just went straight for there to there as well. You see, negative half cos 2x plus a third cos cubed x. They didn't show any working either. Okay, so yeah, that was that. Let's get rid of this now. Limits 0 pi over 2. Substitute them in and then just work out what you get. So pi over 2 cos pi times it by 2. Cos pi is going to be negative 1 times by negative a half. So that's 1/2. And then cos pi over 2, that's 0. So that term's will be 0, so that's easy, got a half. Then subtract, when you put this limit in, let's put it in brackets there. So 0, cos 0 is 1, so that's going to be negative a half. And then plus cos 0, 1 again, of course, 1/3. Yeah, you agree with that? Good, I hope so. Right, so yeah, let's expand the brackets. A half, subtract negative half, so half plus half, that's 1. And then subtract 1/3, and that gives us 2/3. 2/3 square units, okay? And then that's it. Yeah, that is it, okay? So, yeah, hopefully that was good for you. Hopefully you enjoyed a bit of the graph sketching when I actually did this, okay? And hopefully you're able to show a similar amount of work into... Whoa. Shaken, but not stirred. so I couldn't resist. Replay the video. I can't. Yeah, that wasn't an accidental drop. I did it on purpose. Okay, but I couldn't resist. I had to get shaken, not stirred in there somewhere. This is a James Bond thing. Okay. Last bit for you. Okay. I was in Monaco once. Worked in Monaco actually. But I was in Monaco before I worked there. I was in the casino. Okay, and we sort of all went in. We thought, well, better just the casino in Monaco. Yeah. We all went in a bit dressed up, almost a bit like this, but not quite as tidy. Anyway, so I went in. I waltzed over to the bar, as you do. Okay, I had my hair then as well. Okay, I walked over to the bar, and I still can't believe I did this, but I did do this. I walked over to the bar. And the bartender, said, yes sir, because I was obviously British. He said, yes sir, how can I help you? And I said, vodka martini, shaken, not stirred. I got the stupidest look. You must have heard that millions of times, okay? And as I said it, I thought, I sound so stupid. Yeah, there's only a few people like him that can pull that off, okay? I can't. Okay, anyway, it's kind of an amusing story. Yeah. Yeah. Anyway, that's that. Hopefully you enjoyed that. Yeah, and enjoy the integration exercise, okay? Remember, it's not anything new, it's just recapping the area under graphs bit, okay? Hope you're enjoying it, okay? I'll see you later. Take care.